Hi everybody, good morning. This is a new room in insecure randomness. Learn how and correctly configure randomness and can lead to application compromise. This very interesting room. It's a free room, so everybody can. So it goes quick on it, so you can do the labs. I like this room. It's different way to see in type of CTF or something like go to cryptography and the way that. Forget password work and all of that. So it's a good idea, a nice room. So it's not always as XSS and all type of this top 10 on all of this. So the objective of the room, of course, it's a free room so everybody can read. So understanding insecure randomness, type of random number generator, and seventh entropy, predictable also. So all of this information, if you're done with like CompTIA plus something, is about cryptography, how to generate random number keys and all of that. Of course, for example, now we need to us to make a random TryHackMe plus the IP. So let's add it to our host so we can now we can work in the room later on. So if I get the hosts, so I can just come here, add my IP, and then they said random.tryhackme. And then to test that everything is working, they tell us go to this link. So if I go there, make sure everything is working. So for later on, okay, why is not working? 10.10.55.178 random don't try hack me. uh, .html. Sometimes when you do websites here, try hack me, and then we have this. We'll come back later on to this one, but let's start. I didn't reset the room, reset my progress. Okay, let's start room. So the first one is about more definition. Is as you can read, randomness is of course referred to the lack of pattern predictable in data. So if you generate some kind of numbers, when you look to them, the best way is like, is there random? Is like we say 1, 2, 4. You can 4. You can say 8. You can say 16. This is not random because you see each number is a double multiplied by 2 for the previous one. So entropy is represent the amounts of randomness. You use this term in cryptography because more entropy it means you have more randomness. Low entropy can lead to weak security, increase the risk. So there is no is the amount of randomness. Like sometimes if you try to generate a key, they tell you move your mouse in the cube like randomly in the screen like that. I'm doing now to generate some entropy, or use hardware for that, things like that. Cryptography keys always, if you do the cryptography in a key symmetric, asymmetric key. Cryptography key has set values to algorithm encrypt, decrypt data. We know about this. Session token and unique identifiers. This is also session when you log in. Our unique identifier used to maintain user session for login, log out, and all of that. Seeding that used to generate the random the keys and all of that. Seed refer to provide initial value. The key point on this for this meaning that the same seed will always result in the same sequence. So having the seed, if you can detect the seed as the hackers it is a lab later on, the seed is very important measure. So what measure the amount of randomness? Randomness is measured by entropy. So the randomness, that's why we said it entropy. Then he said, is it good practice to keep the same value, seed value? Of course, because it's always, so we need to change the seed. So, and we can do the lab later on to understand this. So, for example, true random number generator. So we have different type of the terminology. We have TRNG, we have the pseudo random, and you have this. What is that static called? Pseudo is a statical and secure one. The true one usually doesn't use algorithm or software to generate them. So what they usually do, they use hardware. because hardware can we don't set, like for example here initial seed hardware. Sometimes they use like processor temperature, things like that, the things that they're not predictable or random. Even if you're a hacker, you can just really guess what the hardware state is, at least for now. Rely on predictable physical phenomena like thermal noise, that radioactive decay, or I don't know, like a fan or something related to hardware. The pseudo numbers generated, on the other hand, are using algorithm and software. Statistical PRNG that are a bit fast on something that have some kind of less probability you can guess them. So they pass static or random tests. That's math. We said, you know what, this is random and satisfy certain statistical randomness in math. The other hand, there is a cryptographically secure PRNG, a phone PRNG designed for cryptography purposes. This one are more have strict condition on them. That's why usually so this one for fast things you use this one, for high using it, but for more secure use this one, the random one. There's some laptop you have them that they call it TMT or something. If I'm not me, I forgot the name. What they call that? A hardware for cryptography in laptops. Now, if you go to save, you prepare a game involving immediate interaction, because now you can see immediate, so it means speed here to generate random event. What type of RNG would most appropriate for this purpose? TRNG static. For this, you go with the statical because it's fast. This is hardware, it take time. Uh, no, you need to use randomness to generate some kind of reality there. So the B will be best option for this. Now we can insufficient entropy. Now we can start testing things. So the case we have in here is, of course, they tell us there's a mail server. If I want this case, and there is mail. If you go to the mail access here, I think the email is, what's the login again? Victim at mail random and the password testing at 123. Let's log into the email and testing with a tcap, testing at 123. So this is basically a scenario to understand things. For example, now if I say username, I said I forgot my password, my username is like victim. If I say send a recent link, it said password recent link has been sent to your email. So if you come here, refresh here, and then we got a recent link. If you click on it, it showed this token equal victim and 173 whatever. Now if I go to timestamp converter, where is the timestamp that usually I use? Usually I use this, but let's see what TryHackMe is saying. He gave us some website new. Let's try something new. Okay, TryHackMe said to us to use this link. Let's use this link. So in case someone following the room and using the same thing, let's use the same unique time converter. So consent, okay, this cookie. So if we take this number here and copy it, and you say, what is this? It's Wednesday, January 15th. So we can guess this is a timestamp. GMT 0 is my time clock now is 8. So TryHackMe server is running, and what the hell? It's 673. This one is 626. Why TryHackMe is what type of 627? This one 626. You can see it means using time. So this number is a time. So now basically it means if I know the person username, I can just create a script and play in the time, like play around like 10 seconds, after 20 seconds, 60 seconds, and check all of them and see which one is working. So this one, it means the entropy is less. And you can see if we go to explanation of this room, it talk what with or insufficient entropy. This thing covers scenario where random number generation suffer from poor or insufficient entropy. So in this case, what, for example, if an encryption key is generated using low entropy data, because timestamp changes each 1 second, so basically it's not really that random. An attacker could use this prediction information to reduce the complexity of finding the key. Poor entropy, for example, system clock, predictable user input, things like that. So these ones are not secure. You can guess them. So now if you have this, and it give us an example how the code work, because the code just say select a username, because we give him username, and then just add the user ID and then add the time. This was exactly we got. The user ID is victim and the time is that one. So basically now uh, this is what we've been talking about, the time function that we use, that use this where is the time function was generate the time. And then yeah, so basically we just need to create a script that, for example, in this one it play with a range from 300 to 0. Basically take the few try token within the range of minus 5 minutes. So if we take this script, for example, because this script basically what it do, just generate a timestamp. So let's do call it this. Just it's a Python script. Choose a vim gen dot. Let's call it gen.py. You can call it whatever. So if I run let's call the norm use Python. Let's do 3.9. I say gen.py. I just give him the victim, the username, and just give him the time. So this script you just give him and the time. So let's do the time. For that, let's do this. Let's get forgot the password again. Let's go back there. The victim. No, not victim. And then of course we have this website to give us the timestamp. But before we do that, let's first generate the link. But we know the time, and then we just refresh this page to get and then press copy. You need to refresh it, so the script is take that for you. So if I go now that and ask him, now we start trying invalid to find the right timestamp, and he give us the timestamp there. Now we know the script. Where is it? So we know the script, for example, like what it use this reset password token equal. So if I want to do that, I can just do that, and then I know the token now is this one, because remember we just check in the next second of the script, the time function that generate. So in our case I go there, okay, and I can just change password to password, for example 123, password 123, and then if I log now to victim, password 123, and I get, and you can see the email already we got there. It's a 1664. It's what exactly our script was detected, 1664. So basically you check a second, next second, next second, next second, which one, because you, in case the servers are running in loop or something, or maybe this the code like run certain time or wherever. So you play in the, what, how many seconds, like you play in the like in the script of 5 minutes or something. So in this case we got the first flag, which is this one. We can answer this question. The function that use we talk about this function is the time function, so we already know the function that generate the code is the Where is it? The time function. Now the next question, it will do the same things, but now for user, what's the name? User master. So if we do the same things, let's log out from this. Let's say in this case the user master. We can do the same. Say send the reset link. Did it send? Okay, it just then we can refresh the timer here. We can copy this. We can come here. We can change there and say the user is a master, and we can just paste the new timer there. We got it. The link, our link, what is our link again? Our link is in the email. We can just copy it again. Reset password token equal. We can come here, and then we know the token that work for us is this one, and then we can just pass it there. Let's use the same password. Password 123. And if I log now as master user, don't freeze on me, TryHackMe. Master password 123, and then if I log in, I get should get the flag of the master of the admin user. So we can copy that, and we got the second flag. So basically the reason why this script didn't work, because the developer who created in this case use the time, and the time it mean, it just changed by second. So whatever even if looping or something, you just try 1 second, 2 seconds, 3 seconds, until one work, because you already know the user ID. So in this case we just need to know the user ID, and basically we can get. So this is a classic case when you have insufficient entropy. So we got this task, this one, but related to entropy. The next task is the predictable seed. Remember we said before, there is the randomness depend in the entropy. Then we have the seed, what the starting point for generating the randomness. So an example impact predictable seed, like capture system or something. And then in our case it's good to understand this, as I said, is free, everybody can read. But now let's practice. In this case, which one? If you go now to this room, let's log out so we don't keep too many. This one we don't need it. Let's close it. I don't think we need that. Look, for example, now if I go forgot password again, no, not forgot password. Let's go back again. We have this login with a magic link. Basically, login with a magic link. So if I want to log in magic, I just put the email. So in case now we have victim. If I want to log in, so victim at mail.random.tryhackme. If I click there, magic link has been sent to your email. If I come to my email and say refresh, I got the email. So if I click on it, I logged it as a victim. So this would give us a flag. It's straightforward, the flag for the next question. This one we have it before. Oh, this is magic. Oh, I forgot. We did this before. But in any case, it show you how you can log in with that. But if you look for this, what it say? Token equal mjk whatever a4. Now where is our friend? Cyberchef. So whenever you see some strange numbers, just always go to our friend Cyberchef. Cyberchef said is what? Is a no, I don't need times. It's not a timestamp. What's going on here? I'm confused now. I thought did room. What? Oh, this is for magic. A user magic. Uh, is a base 64 version of random number generator using PHP. So this one is it's a number in base 64. That's the whole point of it. So this token, what you call magic number in this application, is a base 64 of something in a random number. So in this example, you're talking about magic mail random TryHackMe. Of course, here remember, the whatever you hack, you need to know part of the code. It's not like just a simple guessing here. It's not a guessing game. You need to know how the application. That's why code review and reading the code is important. So you're not solving this problem if you don't know the back-end code of it, because you can just see it's doesn't mean if you know this, so you can guess what is this number like that. Like here, it tell you is a timestamp. It's not a timestamp. Then, so if you look here in the function, the seeds start with constant value. So is this something constant doesn't change? So if here there is a problem there, then CRC32 of the email. So we just do the email with this CRC32. So when user requests magic lane, the server sees the random number generator using a combination of dynamic value. The seed is generated by CRC32 value for user email address plus a constant. That's the problem, the constant value. These two elements are combined from the seed. When you get then the rand start, random number was generated through the seed. But remember, when you have the same seed, you get the same sequence as we talked before. Once a seed is set, the server generates a random using empty rand. This random number is then base 64 to create a token, and that's what we get. Now, what's the weakness of this? The weakness is we can get the constant because the CRC32 is only for the email. So the use of empty rand function weaken the security of the system. Empty rand is a pseudo random number generator, which means that its output is entirely determined by the seed. This is where the whole point is. If you know the seed, once the seed is known, all subsequent output of empty rand can be predicted. Now, in this example, for example, they is work with the email magic. We don't have the login. Well, we have a magic login. Let's because I logged it as a victim, let me log out. Let me log as magic at random dot tryhack no mail at random, and then the password is testing at 123. Now we don't have, so let me go so we know email is magic at mail at dot random dot TryHackMe. So if I send magic there and refresh, now we got the magic, and that's the number, the base 64. If I go to our friend there, let me remove this. Oops, I don't need it. So it's 11356. So we got the first one, and then now we got this in our case this number, which exactly we got it there. So the question now is we need to the seed. So the next step with the tool setup is to crack the seed based on decoded random number. Now there is a tool TryHackMe gave us in the room Insecure. So if we go there, cd room Insecure, we have this PHP binary. It seems that's the one that to crack with it. So if I give him this and ask him what seed of rand PHP function pseudonym was able to generate this one, it takes few time, but the output I know my computer, it takes few minutes I think to, but it give you this. But if I think if the way instead it will give you different seeds, like for example the first this seed, and then they have this seed, this. This is more like you need to try a guessing game a little bit to find the correct one. So the PMC will output a list of possible seeds that could have generated. Remember, this could, it's not like a certain. This may take up few minutes depending on the range of possible seeds. When using PHP empty seed, the two gen multiple possible seeds because different seeds can produce the same initial number. This happens due to the way, so it's related to this function itself. To accurately identify the correct seed, each one must be tested in the environment individually. So you test in, so TryHackMe give us like shortcut and it tells us exactly that. You know what, this one works. You can test the other one, you don't get the magic link, you can't log in, so until you find this one and that one work. Now, so we know that, so let's remove this because now we need to this email that we know, we need to magic at mail.random.tryhackme. We know it used that crc32 checksum, and then we need that hex from base 16. I think it's 16. We need to do the hex, and we have this 97032, and then when so we have 970 321797. So we have this, and now remember when we talk about the way this what is that script running again? Not this one. You see here what it do. There is a constant, and then we have a CRC. So if we have the seed, so the seed minus the CRC will give us the constant. So we got the seed is 97 after you need to try, and so TryHackMe it give us directly the seed. So this one minus the triple one, the double one, it give us the constant that this function is using, and it is 1337. This is the constant of minus. So this the 167 in this our case, this one, and then you have the seed minus of them, you get the constant. So this one, that one, this one plus one, you give you the seed. So basically it's part of this this script. Constant plus the CRC give you the seed, so we can do the minus and we find the constant. Because now we have the constant, we done. We can get any email. Let's test it first for the magic. Now they give us here an easier way to get. They give us a PHP script. We can use this one to simplify our life for this. To get to genetize the token. So for this. Okay, so mine is almost finished. Let that one cook. Let's say if a script call it vim. Let's follow the same naming of TryHackMe. Magic link login.php. You can call it whatever you want. Link magic link what? Login.php. .php. So let's copy there. Of course it's PHP script. Now let's run a server, quickly server in -s000. This is not a Python, so we can do port 8081. Let's follow the same structure of the room. I use 8181. You can use whatever you want. Now if I go to localhost, because it's inside the attack box, 8181, we have this script, and this script, what only we give it, so we only give it the email and the constant, so email and constant. So the email in this case is magic@mail.random.tryhackme, and then you can pull the constant on it. Constant is 1337. Remember, the constant is what we found there after minus the seed, and the CR32 is 1337. So if you have 1337, then you get this. As I said, because now he's trying different seeds in case doesn't work the first one, you can try the other one. That's why he's doing a loop here from I to 0 less than 10, and he keep pushing the emerald in case. And then of course the magic link, we know how it works, so we just need to go there, token. So if I came back now there, so if we try the first token, for example, copy that, the first one, and then let's see if we're able to log in. Oh, we didn't request. Oh, we already there because we requested. So then we can get the one. Then they tell us to practice is try with HR. Let's try now with HR. For HR first we need to request it. So let's go this and make sure. So the user is HR at mail.random.tryhackme. So we request for HR. Remember now, the constant is the same, so the application use the same constant. Is not changing with the image, so basically we can use the same script. So we can just keep the constant and we can just use the email HR here. So HR, what's on my computer freezing now? And then we got this list of things. Then where is that copy again, that key? Let's log out here. So their token, then we can get, this is the HR, the same constant, because the application is not changing. Let's say if the first one work, if I put there and it does work correctly, and we get the HR login. So the problem of this, okay, let's finish the question before. What is the PHP function used to seed the RNG? The seed is the seed one. Where is it, that function the script is running? It's the mtc rand. That's the function that is using. So the problem of this script is this constant. The fact we have a constant now, it's given. So with a constant, we'll be able to detect the seed through this PHP binary. We're able to detect which seed it will work. And then because we have a constant, now we just need the email. We just need the email of the user. Any email of the user use the same constant, so we can get always, we can log in and to this application. So, and this is why you don't use so the problem in this script is the predictability of the seed. The seed, the empty rand is also, is not, I don't think, yeah, the use of empty rand, no, why you said empty rand? Oh, the empty rand didn't generate. So the predictability of the seed, we'll be able to detect the seed in this case. Guys, you can read more about it and try maybe to, if you have if you want to understand more about it. The mitigation, you can think about it. So identify weak random in code during code review. That's why, for example, I love to TryHackMe to do more room about code review or application assessment. Look for use of weak random. So that's why, for example, if you are doing an application open source in GitHub or something, they just search for this function. It weak random numbers generate like empty rand, especially when they generate security sensitive value. Reverse predictability token, PHP, the tool. So this is tool can help Penta demonstrate how predictable token the test token exhaustion if cryptography is secure, a pseudonym number generated. Okay, this one. Then of course secure code developer. Use cryptographically secure PRNG. Always use so we can use this ones random bytes or opens as a random pseudo in PHP or Java. So basically that's it. So if you're doing code or if you find this function state, flag it, tell the developer to switch to these ones are more powerful. Don't use timestamp, IP address, or IP. I think it's a good idea to have a room that use these things uh, and see if people can solve it. Any case, now which of the following can be considered as a weak seed value? Right, seed timestamp is weak, IP is weak, seed digit constant value is weak. So basically, is all of them. Don't use any of them. Conclusion. Okay, go to Discord or X account and okay, guys. I hope. Thank you very much for watching. Hope you like it. Help someone in case someone's stuck somewhere. Please subscribe to the channel. It helped me to keep moving forward. Thank you very much, and yeah, have a good day and good luck.